Welcome back, mathematicians. Today we are going to talk about and analyze power functions. Power functions are in the form of f of x equals ax to the n. We are going to specifically look at the first 6 power functions, what their graph looks like, and how you can tell them apart, and also what their form looks like. Then we're going to talk about general form between even power functions and odd power functions. Finally, we're going to look at 2 different power functions and analyze them based on all of these parameters. This is the first and is an even function, and this is the second and it's an odd function. If you want to skip to any of these parts specifically, check out the chapter links in the description below. Let's get started describing each of these power functions. So first of all is the constant function. A constant is a pure number that does not have a variable. So although we have this form of function, the truth is the x value is going to be to the 0. So I'm going to go ahead and write a constant function here. What this means, an example of this would be like f of x equals 4. Now technically a constant function does have an x variable, but it is x to the 0. And remember, whenever we have anything to the 0, it turns to 1, and 4 times 1 makes that 1 disappear. So a constant function is a function that's simply equal to a number. In this case, in order to graph a constant function, you go to wherever it is going to cross the y-axis, whether positive or negative. This is a constant function. The second type of function we're going to talk about is linear. A linear function has x to the first power. So we can look at a linear function as simply being f of x equals x. Now an example of a linear function might be 2x or 1/2 x or even negative 3x. And all of these coefficients, which are represented with the form of a, would change the way that the linear function looks. But to graph just the parent graph of a linear function, we're going to make a 45-degree angle right through the origin. And that's a linear function. Now, these 2 functions are straight lines. After that, we start to get into curves. A quadratic function is a function that's in the form of f of x equals x squared. This is when n equals 2. That's a quadratic function. An example of this might be f of x equals 2x squared or 5x squared or even negative 1/3 x squared. But the point is n equals 2. In order to graph a quadratic function, we're going to make what is known as a parabola. To leave a little bit of room for our parabola, I'm going to go ahead and move this function down here. A parabola is a U-shaped function. In this case, the parent graph is going to move upward like a smile because there is not a negative a in front of x squared. And this is the shape of a quadratic function. Next is a cubic function. A cubic function is in the form of f of x equals x cubed. So to the 3rd. Go ahead and fix that x in there. A cubic function looks very similar to a quadratic function. half of a cubic function, the positive half in the first quadrant, looks exactly the same. But the other half, because it's cubed, is able to be rotated about the origin. It's basically the other side of a quadratic flipped upside down. That's the shape of a cubic function. Now, after cubic, the great thing is that quartic and quintic are going to mirror quadratic and cubic. Let me show you what I mean by that. A quartic function is in the form of f of x equals x to the fourth. And it is also going to be the shape of a smile going upward. As long as the parent function hasn't been changed, it's going to go upward. You'll notice that the quartic function is also a parabola, just like a quadratic. This leads to our last example, quintic, which is in the shape of a cubic. A quintic function is in the form of f of x equals x to the fifth. And just like cubic, it starts off looking like a quadratic and then flipping the other side of the quadratic upside down. And in fact, I probably should spend a moment drawing this just a little bit better because it will be steeper than a cubic function. Although we're not using any values, I want it to look just slightly steeper. Now, the fact that quartic and quintic mirror quadratic and cubic shows us our next principle, which is even and odd. Even refers to the exponent in a power function. So, in other words, even functions are going to be x squared, x to the fourth, x to the sixth, and so on. Even functions are all going to be in the shape of a parabola, a smile that is shaped upwards. Each time the even function goes higher, it's going to make the parabola steeper. As you can imagine, each parabola is going to go up faster and faster based on the power. Odd functions, on the other hand, are functions that have odd exponents. X to the third, x to the fifth, x to the seventh, and so on. These are going to look like a cubic function. There's a 3-point curve. And if you look, it looks similar to, and in fact, I've not drawn it quite as similar. Let's see if we can try that again. A parabola with the other side turned upside down. They're not easy to draw. X to the fifth and x to the seventh then are going to get steeper and steeper. As you can imagine, that they're going to increase in value much faster. Let's go ahead and analyze an even and an odd function. The first function we're going to look at using our handy-dandy online graphing calculator Desmos is an even function. I know it's an even function because the exponent is a 4, and 4 is an even number. There's a couple things I'd like to point out about this function before we start to analyze it. First of all, it has a negative in front of it. Remember that power functions come in the form of f of x equals a x to the n. In this case, our a is negative 1/3, and our n is 4. N being 4 is what makes it even, but a is how the graph is adjusted otherwise. The fact that it's a negative is the reason that this is flipped upside down like a frown. The fact that it has 1/3 is why this is flattened out at the top before it starts to curve. If I were to zoom in, you would see that this is still indeed a parabolic shape as we get closer and closer, but it goes up much slower because it's being cut into thirds. Now let's go ahead and talk about domain and range. Remember that domain is when we go to the x-axis and we see if we are able to touch the graph. And indeed, no matter how far we go down or up, we would be able to touch this graph. So the domain of this function is all real numbers. In other words, it goes from negative infinity to positive infinity. Range does exactly the same thing, with one very important exception. As long as I am within the curve, the range is going to continue to exist. But as soon as I go above 0, there isn't anything up here. That means that the range is all real numbers, with a very important exception that y has to be greater than or equal to 0. Now, if either part of that was confusing at all, I do have a whole nother video discussing domain and range at detail. So let's talk about x-intercepts and y-intercepts. X-intercepts and y-intercepts are where it crosses the x-axis and where it crosses the y-axis. The very lucky thing here is that it's going to cross at exactly the same point. This function only touches an axis right at the origin. So 0, 0. Let's talk now about increasing or decreasing. Remember that when we're talking about increasing or decreasing, the interval is the x-axis, but the increasing is going to be whether it's increasing or decreasing in the y direction. That's a little confusing. I do have another video on this as well. You can see that if I were to follow the function from its smallest points, it's going up, 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 up until it hits 0. It's increasing on an interval from negative infinity to 0. It does not include 0 because at 0, it's neither increasing or decreasing. After 0, it starts to go back down. So we're going to say it's decreasing on the interval from 0 to positive infinity. Let's talk about symmetry. Symmetry might be a new concept for you. Up until this point, you have discussed all of these probably in your precalculus class, and I've definitely discussed it in other videos. Symmetry, on the other hand, is new for this lesson, usually. In this case, even functions are going to be symmetrical about the y-axis. As long as we haven't altered this even further by putting complications in here, we will always be symmetrical about the y-axis. That means that if I were to draw a line right at the y-axis, and in fact, let's make this just a little bit thicker so that we can see it better. The graph is going to look exactly the same like a mirror image on the left and the right. So we can put symmetry is about the y-axis. There are no discontinuities in this function. Discontinuity would be maybe if we had a little hole right here, because the function would specify that it cannot cross there. Or if we were working with piecewise functions and the function actually stopped here and maybe picked up and went in a different direction. This function, on the other hand, is continuous. All the way from negative infinity to positive infinity, there are no discontinuities. So finally, let's talk about end behavior. End behavior is as x approaches positive infinity and x approaches negative infinity. We're going to talk about what do the ends do down here. What are they doing? So as x approaches positive infinity, the function in terms of x approaches negative infinity. Let's look at that and see if that's true. As x is going this direction, the function is going down. So as x approaches positive infinity, the function is decreasing. All right, let's check the other direction. As x approaches negative infinity, this direction, what is the function doing? It's also going down. So the function is also approaching negative infinity. Let's go ahead and try an odd function. I know that this function is odd because this number here is odd. I want to look at a couple of other things. A, in this case, is 2. N is 5. This means that this function is going to go up twice as fast as the parent function. But you'll notice it is the exact shape of an odd function. Let's look at the domain and range. Once again, if we consider every x value, the domain is going to be all real numbers. Unlike an even function, though, the range is not going to be limited in this case. No matter where I go on the y-axis, I'm going to hit all the numbers as well. The x and y intercept, however, is exactly the same. Since this hasn't been altered with complications, it's going to be right at the origin. Now let's talk about increasing and decreasing. If we look at the graph, you will notice that this graph is just continuously increasing. It starts off increasing at negative infinity and continues at positive infinity. This means that there is no decreasing interval, and so we would write none. Symmetry in an odd function is different than it is in an even function. It is not symmetrical about the y-axis. It is not a reflection. Remember that if we had an even function, this would be reflected about the y-axis. Instead, this is rotated about the origin. You can see that if I took this part of the graph and swung it around, it looks exactly like this part of the graph. So we say that odd functions are symmetrical about the origin. Once again, this graph has no discontinuities. There are no parts of this graph that are broken. Finally, let's talk about end behavior. End behavior, remember, is that when we have x approaching positive infinity, what is the graph doing? And when x approaches negative infinity, what is the graph doing? Now that is a seriously ugly infinity symbol. So let me redraw that. So in other words, when x is getting bigger and bigger and bigger, what is the graph doing at the same time? And you can see that it's approaching positive infinity. But when x is getting smaller and smaller, what is the graph doing? And this time it's approaching negative infinity. So you'll notice that its end behavior is opposite, and that makes sense. One side's going up and one side is going down. I hope that helped to analyze power functions. Don't forget to like and subscribe. Good luck.